The next layer that we want to discuss is going to be layer 2. Now, layer 2 of the OSI model still is referred to as the Datalink layer. Now, the Datalink layer has responsibilities. Now, remember, the Datalink layer, we're moving up. We just talked about the physical layer. So when I had my two hosts that I need to have communicate with one another, remember, we had the network interface cards, the NICs, any repeaters or any of the hubs that we have in our infrastructure, which are have pretty much gone the way of the dodo, are going to be connected to my physical media. So this would be, as an example, my Ethernet segment. Now, with this configuration in place, we now need to understand what the data link layer does for us. So first of all, if this is part of layer 1, it's important to understand that on top of layer 1, I have layer 2, my data link layer. Now, a lot of people aren't aware of it, but the data link layer is actually comprised of 2 sublayers. So the data link layer in its own right is comprised of 2 sublayers. The first layer is the media access control layer. Now, the media access control layer has a number of jobs. Among them is that it is going to ensure that we control who can access and when they can access the actual communication media. So this is going to basically offer me, like I said, those features with regard to access control. It's also going to make certain that we have what we refer to as uniform frames. Remember, we talked about the fact that I communicate in protocol data units at layer 2 in Ethernet, and the name of those PDUs are called frames. But the thing is that in Ethernet, all of those protocols, all of those protocol data units need to be of a uniform size. Well, it's the access control layer that actually accomplishes that for me based on principles called bit and or byte stuffing. So what we're going to do is that we're going to actually make certain that the frames are all the same size, and the information that is going to be contained in them is all going to have the same format. So it's going to have my end of field, my start of field, which is going to say, hey, this is an actual new frame. And that's all handled by the media access control element. We call this the MAC layer, media access control. Now, the next layer that's all part of this is also what I refer to as the logical link control sublayer. That is referred to as the LLC. Now, the job of the LLC is one, to ride on top of the media access layer. The media access control layer or sublayer is, as I said, responsible for all of this. But it doesn't offer us some features that we really do need. So as an example, the logical link control mechanism is responsible for, excuse me, it is responsible for multiplexing. So if I multiplex anything, what I'm doing is I'm taking multiple pieces of information from different sources, and what I'm doing is I'm actually allowing those devices or those communications to actually be sent sequentially one after another. And then what I do is I rely on a concept called reassembly as they arrive at the other end. So as information is leaving out of here as ones and zeros at the physical layer, it's important to understand that these ones and zeros may be different from another stream of ones and zeros that are a part of a different communication, but through this idea of multiplexing that's provided by the link layer, the logical link control mechanism, the LLC layer, what ends up happening is I can actually send this information across the same line through this construct, or this idea of multiplexing. Now, another thing that it also does for me is it gives me something called error notification. Now, error notification is letting me know that there is an error. It is not going to correct that error. So just keep in mind that that's set up and it's working. Also built into the LLC that runs on top of the media access control sublayer is going to be things like acknowledgments, confirmations, and things along those lines with the ability to be able to send information. But most pivotal is going to be this idea of multiplexing and this idea of error notification, which becomes very, very important to us when we start actually serializing information and sending it across these links. And remember, as that information comes down from the data link layer, it is encapsulated. And as that information arrives on this end and is relayed up, that information is de-encapsed. Let's say it is de-encapsulated. So again, one model providing services to the other. Protocols that run, devices that run at this level. So at the link layer, it's important for us to understand this is going to be where we find devices like switches. You know, gone are the days of hubs and concentrators. So what we want to do is we want to have switches in our infrastructure because switches are intelligent. Switches maintain databases like content addressable memory tables, something that you guys may already know as, say, a MAC address table. And all of that information is actually learned from the media access control mechanism. And it allows me to record addresses that operate at layer 2, and again, we call those media access control addresses or MAC addresses. Every network interface card you buy is going to have a unique MAC address. Every switch that you buy is going to have a unique MAC address for every port, plus the switch itself is going to have a unique system MAC address. Other components or other things that operate here at layer 2 would be protocols. So as an example, this would be devices. Now, if I have switches that operate at layer 2, also it's important to note that I have protocols that operate at layer 2. So as an example, some that you may have heard of is Cisco Discovery Protocol. The industry standards version of Cisco Discovery Protocol, LLDP, Link Local Discovery Protocol. It operates at layer 2. When we start looking at things like Spanning Tree Protocol, VLAN Trunking Protocol, VTP, these are all protocols that operate at layer 2. Now, I'm keeping everything defined in terms of Ethernet because that's the media that we're going to be using in almost all of our demonstrations and definitely in our conversations discussing theory. There are other protocol types. I mean, I could throw out Token Ring, ArcNet, all of these different things, but it's important for us to understand that these protocols that we're discussing are modern protocols. Other functions that take place inside the configuration when it comes to logical link control is going to extend into the layer 2 functionality would be things like carrier sense multi-access collision detection and carrier sense multi-access collision avoidance. Now, CSMA-CD is still a thing. It's just understand that in a modern device like a switch what we do is we absorb those collisions. And that's all made possible due to the fact that these devices are optimized to operate at layer 2 of our OSI model. So to have a firm grasp of how to, first of all, determine how a switch is going to operate, and second, probably more importantly, how to fix it when it's not working or how to determine whether or not it's not doing its job, we need to have a firm understanding of the principles behind the layer 2 of the OSI model, which governs the behavior of data link and data link performance. Next layer we're going to discuss is going to be layer 3. I'll see you guys in that video.